We are taking R.D. Sharma solution. We are taking chapter number 16, tangents and normals. And this is VSAQ. Very short answer questions. Find the point on the curve. This is the curve where the tangent is parallel to x-axis. So, if this is a Cartesian coordinate system, now this tangent which is parallel to, or any line which is parallel to x-axis, how do we find out the angle? The angle is the anti-clockwise direction from the positive x-axis, right? So that is what we call it as a slope or tan theta, or there are dy by dx, many names. So when the line is or the tangent is parallel to x-axis, the slope is 0. So let us differentiate this curve equation. We'll find dy by dx, and dy by dx is given in the question as 0. So let us find out the slope. I'm differentiating x square minus 2x. That will give us 2x minus 2, and that is equal to 0, because the slope is given as 0 because the tangent is parallel to x-axis, and as I explained, it is 0, so 2x equals to 2x is equal to 1. So we put it here. So y will be equal to 1 square minus 2 into 1. I'm just placing this x in the original equation in order to find out the y. Y will get 2. So this is 1 comma 2. Now this is the reference solution for you if you want to pursue it yourself. Find the slope of the tangent to the curve, this one and this one. Now this is the parametric form at t is equal to 2. So dy by dx we want first of all, because here we can get dx by dt. Here we can get dy by dt. In order to find out dy by dx, we have to divide them. So we'll put dx by dt in the denominator or dy by dt. And whatever value will come, we'll just put t equals to 2. So dx by dt will be what? It will be 2t. This is going to be plus 3. No problem here. Here dy by dx. So it will be 4t minus 2. Now just divide these two in order to get dy by dx. So when you divide these two, it's 2t plus 3. This is your dy by dx at t equals to 2. What will be dy by dx? Because this is slope only. So 4 into 2 minus 2 divided by 2 into 2 plus 3. So 4 to the 8, 8 minus 2 is 6 in the numerator. 2 to the 4, 4 plus 3 is 7. So what do you get? 6 by 7 as the slope of the tangent. So this is the reference solution for you. It's quite straightforward and easy question. I hope you'll be able to do by yourself. If the tangent line at a point P, x, y on the curve this is parallel to x-axis, then write the value of dy by dx. In the first question we have already discussed. See, if we want to find out this angle of this line or slope, we'll take it anti-clockwise from the positive x-axis. If a line is parallel to x-axis, that means it is almost equal to the x-axis. So angle with x-axis is 0. That is why dy by dx is 0. How are you going to write it? This is the whole content you have to put in on paper. Write the value of dy by dx if the normal to the curve y equals to fx at xy is parallel to y-axis. So they are not saying tangent first of all. They are not saying parallel to x-axis. First of all, it is normal, and normal is parallel to y-axis. So the tangent will be parallel to x-axis. Okay. Normal is this angle only. So this is 90 degree. So what is tan 90 degree? It's tan pi by 2 is infinite. So the normal slope is infinite. You have to find out the slope of the tangent, and slope of the tangent and normal multiplied, if you multiply them, you are going to get -1. That is, if you have a m1 which is normal, m2 which is tangent, multiply them, you will get it as -1. So tangent is equal to -1 by infinite. If you divide anything by infinite, it is going to be 0. So tangent slope will be 0. And simply saying, if line is perpendicular to or parallel to x-axis, it is perpendicular to a line which is parallel to y-axis, this is going to be the result. So let me show you how you are going to write. So this is the reference solution for you. If the tangent to the curve at point xy is equally inclined to the coordinate axis, then write the value of dy by dx. Now, so we have to find out the slope. Okay, I am making a line and you are very well aware of this line. So this is 45 degree from y-axis, 45 degree from x-axis. That means it is equally inclined to the coordinate axis. So you will be tempted to answer dy by dx tan 45 degree, because the slope is nothing but the angle from the x-axis taken in the anti-clockwise direction. What you will do? Tan theta you will find out, because it is 45 degree, tan 45 degree, it is going to be 1. You will answer it is 1. No, it's not 1. See, dy by dx, tan 45 degree or tan theta, all these are same. So this is going to be 1. But as I'm saying, if I make a line like this, this is also equally inclined to the coordinate axis. So there will be two lines, and if you make the anti-clockwise direction computation of the angle, the slope will be negative. Basically it's tan minus 45 degree, and you know tan minus theta is minus tan theta. So it will be minus 1. Plus minus both will be the answer. So this is the whole scenario which I just explained. This is how you're going to go about it. If the tangent line at a point xy on the curve y equals fx is parallel to y-axis, find the value of dy by dx. Now you have a Cartesian coordinate system. Tangent is parallel to x-axis. Not parallel to x-axis, sorry, y-axis. That is, the angle is, what is the angle? Pi by 2. And you know tan 90 degree is what? Infinite. Tan 90 degree is infinite. So what do you think the answer is? It has to be infinite. A tangent line which is parallel to y-axis, the angle from the anti-clockwise direction of x-axis is 90 degree. Tan 90 degree is what? Infinite. So the answer should be infinite. But I would like to show you one more angle to this, because in various solutions, various resources, I would like to put in front of you. See, so this is kind of solution they have given, but I would like to tell you that if it is parallel to y-axis, tangent, this angle is 90 degree, tan 90 degrees is infinite. So if you want to find out the normal slope, it will be 0, but it will be infinite in the case of whenever it is parallel to y-axis, because the angle is 90 degree. Find the slope of the normal at the point t on the curve x equals to 1 by t, y equals to t. So you just have to differentiate, find out dy by dx. When you find out dy by dx, just let me do the dx by dt. It is minus 1 by t square. Dy by dx, dy by dt will be 1, just divide them. So dx by dt will come here. So it will be 1 divided by minus 1 by t square. It will go up. But we don't have to do this, because see, the slope of normal has to be found out. So we have found out the slope of the, which one? Tangent. Normal and tangent, if you multiply the slopes, you're going to get -1. That means you have to find out not dy by dx, you have to find out -1 by dy by dx. So minus 1 by dy by dx. So we have minus 1 here. What is dy by dx? It is minus t square. So minus minus gets cancelled. You will get 1 by t square. And since there is no t, this will leave it with this. So the step-by-step discussion is this one. You have to follow this while writing. Write the coordinates of the point on the curve y equals to x, where the tangent line makes an angle pi by 4 with x-axis. Pi by 4 with x-axis means what? We have just seen a question like this. This is 45 degree. The line is equally inclined to x-axis and y-axis, coordinate x-axis. So tan 45 degree is what? It's going to be 1. So dy by dx is already given in the question. It is dy by dx, tan pi by 4 is 1. So when you differentiate this, 2y dy by dx equals to 1, dy by dx is equal to 1 by 2y. Okay, and that is equal to 1 because the slope is 1. We already found out tan 45 degree is equal to 1. So just equate it to 1. When you equate it to 1, 1 by 2y is equal to 1. So y is equal to what? Y is equal to half. Just put it in here so that you can find out x also. So when you put this y as half square, x will be equal to 1 by 4. So the coordinate points are x and y, that is 1 by 4 and 1 by 2. X comma y is what I have written here. Now let me show you, this is the whole scenario you have to follow step by step, and then you have to give the answer. Write the angle made by the tangent to the curve x equals e raised t cos t, y equals to e raised t sin t at t equals to pi by 4 with the x-axis. Now again, parametric form, dx by dt, dy by dt, you have to find out dy by dx, so just divide them too. But please remember sin pi by 4, cos pi by 4, that is cos sin 45 degree and cos 45 degree, they both amounts to 1 by root 2. That is what we are going to use just now. So let us take dx by dt. So I am using the product rule. So e raised t cos t will be minus sin t plus this is cos t, e raised t is e raised t. Now this dy by, now let us, because I am going to divide it directly. So let us find out dy by dt. Again I am using the product rule. E raised t cos t, then sin t will remain like that. E t will be et only. And dy by dx will be found out by dividing dx by dt, means putting it in the denominator. So I am just putting this negative et sin t plus cos t e raised t. Since et is everywhere, just cancel it out, or you can say divide every term by e raised t or numerator denominator by e raised t. So you will get cos t plus sin t divided by, I am writing it as, because it is negative sin t plus cos t, I am writing it as cos t minus sin t. Now what is t? T is pi by 4, and I already told you sin pi by 4 and cos pi by 4 is 1 by root 2. So why not to replace 1 by root 2 here? 1 by right root 2 plus 1 by root 2 divided by 1 by root 2 minus 1 by root 2. Since 1 by root 2 subtracted is 0, the answer will be infinite. That is, tan theta is infinite. And I have told you theta should be what? Pi by 2, because tan pi by 2 is infinite. So the angle is pi by 2, which is 90 degree. Alright. So this is dy by dx. This is nothing but the slope. Slope is infinite. That only comes when tan is pi by 2. Pi by 2 is the angle from the positive x-axis. Now this is how you are going to do this. This question will be taken in the next discussion. Till then, thank you so much and take care of yourself.